Chapter 8, Part 1b, we'll continue our discussion with linear regression. So whenever we're dealing with a regression line, we always have two things. We have our slope and our y-intercept. So we're going to talk a little bit more in depth about those kind of two items. So in our model, we have a slope, which we call b1. And technically, our slope is built from the correlation coefficient, so your r value, and our standard deviations, which is our sy and sx. So the formula for slope is b1, that's our slope, equals our r value, our correlation coefficient, times the standard deviation of y over the standard deviation of x. Now you do not need to memorize this formula, it will be given to you on the AP exam. They give you a big old formula sheet, and this is something that will be on there. Our slope is always in units of y per unit of x. So it's telling us y per x. In our model, we also have a y-intercept, and this intercept we call b0. The intercept is built from the means and from the slope. So our formula for the y-intercept is b0 equals the average of the y variable, so I'm going to put y bar, minus the slope, so b1, times the average of our x variable. And this y-intercept is always in units of y. So whatever our y variable is, we'll use the same units. Now, sometimes we will get problems where they give us means and standard deviations for both of our variables. If that's the case, then we can use those means and standard deviations to find both the slope and the y-intercept. So our first example here says, a college's job placement office collected data about students' GPAs and the salaries they earned in their first jobs after graduation. The mean GPA was 2.5 with a standard deviation of 0.4. Starting salaries had a mean of $45,000 with a standard deviation of $8,000. The correlation between the two variables was r equals 0.75, and the association appeared to be linear. Our job is to write an equation of the model that can predict salary based on GPA. So this means that we want our GPA to be the explanatory variable so that GPA can explain salary. Now we are going to use those formulas that we talked about above. Before we start jumping into the formulas, I like to write out all of my variables to keep things a little bit more organized. So GPA is what I'm using for my x variable. So I'm going to start with writing out my x bar, the average GPA, and that standard deviation. So this was 2.5 and 0.4. I'm going to do the same thing for my y variable, which is salary. Find the average and the standard deviation. The only other thing we'll need is the r value, which they tell me is 0.75. Now that I have everything organized, I can start building this actual equation. The very first thing that we always want to do is find the slope. We can't find the y-intercept first because the y-intercept uses the slope, so we have to find the slope here first. Again, our slope formula says to take our r value, divide our standard deviation of y by standard deviation of x. So I'm just going to plug in here. I have 0.75. I have 8,000 divided by 0.4. Plug this into our calculator. And I get 15,000. So this is my slope. Once we have the slope, we can then move on to finding the y-intercept. Again, our y-intercept formula says to take the average y minus the slope times average x. So now that I know what the slope is, I have all of these pieces, so I can go ahead and plug in. Again, going to plug that into my calculator. And I got 7,500 for that y-intercept. The last thing that we want to do here is write our equation. And when we go to write this equation, we want to make sure that everything is in context. So in general, our equation looks like this, where we have our y hat, our predicted y. We have our slope times our x variable plus our y-intercept. And you might have those switched. You might write it as your y-intercept plus your slope times the x variable. The order does not matter there, as long as the slope is next to the x. Now, all of these things should have something plugged into them. Instead of just y's, I want to tell what that y variable actually is. So I was looking at salary. So I'm going to put salary, and I'm going to put a hat over salary because this is my predicted salary. I'm then going to plug in my slope. Instead of x, I'm going to actually put what the x variable is, so that was GPA. And then at the end, I can put the y-intercept. This right here is my final answer, the equation for that line of best fit. A few things to watch out for. Make sure in the very beginning you are conscious of which variable is which. If you have these switched, unfortunately, all of your equation is incorrect, it's flipped, so make sure you are conscious of those. In our next example, we will talk about how to reverse a regression line. So the following equation represents the association between hours spent watching TV last week and a student's grade in their math course, which was recorded in percent. So this equation here, hours is the x variable and y is the grade that they have in their math class. What we want to do is find the slope of the line that uses grades to predict hours of TV watched. So we have now switched around those two x's and y's. So there's kind of two things happening here. We have this equation that we're given, which is using hours of TV to predict their grade. And what we want to find is the exact opposite. I want to find just the slope that will help me use grades to predict hours of TV. Now I know that we're working with slope, so I'm going to write out my slope formula. And I'm going to work with just kind of the stuff that we're given right now. I actually do know the slope for hours predicting grades. I can see in my equation that my slope right now is negative 1.34. I also forgot to tell you there is a slight typo on here. We need to add on to this problem. They forgot to include that R is 0.64. Sorry about that. So I can plug in my 0.64 here. There's no mention of standard deviations, so we will just leave those too. Now I know there's kind of two things left. There's two standard deviations, but I want to get those by themselves. So I'm going to divide each side by this 0.64, and I'm not going to type this in my calculator. I'm actually just going to leave it as this fraction. Trust me, you will see why in just a moment. Okay, once we have those standard deviations alone, we are kind of stuck, so we're going to stop here, and now I'm going to switch over to thinking about what I'm trying to find. Now I'm trying to find slope, so I should be still working with this slope formula. And we know that my R value won't change if I flip the variables. So just because I'm switching the X and Y does not change that R value. What does change is the order of the standard deviations. Now that I'm switching my variables, technically I have my SX on top and SY on the bottom. Okay, as I go through here, I know that R is still 0.64. And once I'm at the standard deviations, here's where it's nice that I didn't actually divide this fraction. In this case, I have sy over sx. This is the exact opposite. It's sx over xy. So what I'm going to do is just take this fraction and flip it. So I'm going to have the 0.64 and the negative 1.34 on the bottom. From there, I can go ahead and type this into my calculator. And we get negative 0.31 as my new slope. In our next example, we will talk about how to sketch a regression line. This is actually a question on an old AP exam where they gave you the regression equation or the line of best fit, they gave you the scatter plot, and our job is to draw in this line of best fit. Now, tons of students got this question wrong because they looked at it, they went, all right, just drew in a random line and said, that's got to be it, that's my line of best fit. We do need to see a little bit of work here in order to earn full credit for this. So I think about this problem as kind of 3 steps. The first thing that we're going to do is pick 2 x values. After we have those 2 x's, and it can be any x that's within the range of your values, we're going to plug in the x to find our predicted y. I'm going to call that y hat. And then I'm going to plot those dots and connect to form my line of best fit. So I'm going to start with picking 2 x values. It looks like this is close to 60, so one of them I'll choose as 60. I'm going to take that x value and plug it into my line of best fit. So I have 1.79 plus 0.157 times the 60. Gives me 11.21. So the first point that I have is 60, 11.21. So I know it's not going to be perfect, but I can kind of take an estimate of where that should be. Here's 10, 12, 11. I'm going to pick another x value, and I'm going to make this one kind of further on the right here. Looks like my data is kind of ending around 200, so I'm going to pick that. Again, plugging in 200. And we're going to plug this into our calculator. We get 33.19. So my next point is 200, 33-ish. So 200 Okay, once we have those 2 points, we're going to connect them, and now I have my line of best fit. Your work might look slightly different than mine depending on what x values you chose, but in general, we should be getting roughly the same line here. This last example we have on page 23 is kind of putting everything together. It gives you a regression equation and asks you to interpret the slope and the y-intercept and then find the slope that switches it. There is a small typo here again. I forgot to include the r value. This r should be 0.87. Go ahead and pause your video to try this problem, and then once you're ready, play the video again to check your work. Here is my work for this last example. The only thing that I did want to talk about real quick was this y-intercept. The y-intercept in this case is negative, so we're saying that the model predicts when a house is 0 square feet, so when this x value is 0, that the price is on average negative $3,117,000. Now, this doesn't make any sense. Even if I go and buy just a piece of land, there's no house on there, so that house is 0 square feet. There's no way that it's going to be negative dollars. So if you come across a y-intercept that does not make sense like this, make sure that you include something brief telling me why it does not make sense. So I said, this does not make sense because even land will cost something. Go ahead and take a few minutes to check your work. If you got a different answer, hopefully you can figure out your mistake and go from there.